morning all of you. Today we will discuss about quicksort. In previous lecture we have studied about selection sort, insertion sort, bubble sort. Now today our topic is quicksort. We have to sort this array or any array by using this quicksort. Okay. Now first of all we should know about what is a pivot element. This is very basic thing in quicksort. Concept behind pivot element I will tell you in next lecture. So first of all we should select any of these elements by using pivot element. हमें क्या करना है कि इन सब में से हम एक पूरा एरे दिया हुआ है, वैल्यूज दी हुई है, उनमें से एक पाइवट एलिमेंट सेलेक्ट करना है. हम फर्स्ट एलिमेंट को एज ए पाइवट एलिमेंट सेलेक्ट कर सकते हैं, लास्ट एलिमेंट को कर सकते हैं, बीच में भी किसी वेरिएबल को हम एज ए पाइवट एलिमेंट सेलेक्ट कर सकते हैं. सो लेकिन अलग अलग इसको आप पाइवट एलिमेंट सेलेक्ट करोगे तो एल्गोरिथम दूसरी होगी, इनमें से कोई लोगे तो एल्गोरिथम दूसरी होगी, ये लोगे तो एल्गोरिथम दूसरी होगी. सो I am taking the first element as pivot element today. Okay, we will discuss algorithm depending on by assuming that first element is our pivot element. Okay, sometimes it is also called as key element. Now this is our lower bound. We know very well. This is our upper bound. This is our start, and this is our end. There are two variables more in this sort. We can select a first element as start and last index as end. Okay. How this algorithm will work? First of all, concept behind pivot element is this: once we have selected any one element as pivot element, we have to fix the place for that pivot element. Means हमने ये 7 एज ए पाइवट एलिमेंट सेलेक्ट किया है, इसको हमें इसकी प्रॉपर पोजीशन पे पहुंचाना है. What is the proper position of 7? There are 1, 2, 3, 4, 9 variables. Okay. 1, 2, 3, 4, 5. 5 elements are less than 7, and 3 elements 5. 1. 3 elements are greater than 7. Okay. Now, what will be the position? What should be the position of 7? 9 elements. 7. What should be the place for 7? 1, 2, 3, 4, 5 elements are less than 7 and 3 variables are greater than 7. Okay. Now what will be the position of 7? This one. This is the appropriate position for 7. We will find this by an algorithm. We will shift this 7 to its appropriate position by using algorithm, not directly down. Okay. Now all the elements, this is our pivot element, all the elements which are less than 7 should be before the pivot element's values that are less than equals to 7 and values which are greater than equals to 7. If you are having two elements same, then you can shift that element on either side. You can shift that variable in before pivot element or after. It's your choice depending upon the algorithm we are using. Now, okay. So, how this 7 will be shifted to this position? For that, we should apply an algorithm. After applying that algorithm, we will found that this element is automatically shifted to the memory location, appropriate memory location. For example, for example, this is our start. What should be the algorithm? This is our start. Now, this is our end. Now, if pivot element is or pivot is if this element is less than or equals to 7, then what will happen? Start will be shifted to next memory location. Okay. Again, we will compare this variable with pivot element. Again, this variable is less than or equals to 7. Then again, this element, this start, is shifted to 10. Second memory location 0, 1, 2. Now, if we compare this variable with a of 2, then this element is not less than this, so we should start here only. Now what is the updated value of start? Updated value of start is 2. 2. Now, from next side, from right hand side, we will compare pivot element with this element. If this number is greater than the pivot element, then end will decrease by 1. Less than equals to or greater. Pivot element is 7. Element is 4. 4 is not greater than 7. So, end will remain unchanged. And value of end will not be changed. Now, what we have to do? We have to swap these values. A of start is 10 and A of end is what? 4. Value of start is 2, value of end is 8. Now we have to swap these values. After swapping, we will get what? 7, 6. Okay, now what should we do? We have swapped these two values. Value of start is again start, and this is our end. So value of start is 2 and value of end is 8. Again, value of pivot element remain unchanged. Okay. This is 7. Now, again we will compare this pivot element with this element. If this element is less than this, yes, then value of start will be updated. Again we will compare value of this variable is less than this. Yes, again start updated. Now 9 is not less than 7. So updated value of start is what? This is our start. Okay. Now this is our start. Now I will compare this. Is this variable is value is greater than this? Oh, then end will be decrease. Now again we will compare 7 with 15. 15 is greater than 7. Yes. Then again value of end will be decreased by 1. Now this value is not greater than 7. Now final value of updated value of end will be 6. Final value of end is 6. So start stops here and stops here. So we will swap these two values. Okay. Now swap this with this. So what will happen? 7, 6, 4, 5. 9 will be replaced with 1. 1, 2, 9, 15 and 10. Value of start is 4. Yes, this is our start and this is our end. Again, what? Pivot element is 7. This value is less than 7. Start will be updated. Again, this value is also less than 7. Start will be updated again. Now, 9 is not less than, the final value of start will be what? Final value of start will be 6. Start. Now, from right hand side, is this value is greater than this value? Yes. And it will be decreased by 1. If this value is greater than this, no. So what is the value of end is? Value of end is 2. Now we don't need to swap because value of start is greater than end. We have to swap values. We have swapped values of start and end here. So this time we will not swap these two values because the value of start is greater than end. Here the value of start is 2, 8. We have swapped because value of start is less than end. Value of start is less than end. But this time value of start is not less than end. So we will not swap values. So what we should do? We have to swap A of end with A of LB. A of LB. So A of LB is 7 and A of end is 2. So we have to swap these two values. So 2 becomes yeah. So after this, when your start exceeds value of end, then we have to swap A of LB with A of end. So now you can see that we have found the appropriate position for this 7 because all the elements before this are less than the pivot element, or all the elements after this 7 are greater than pivot element. Not necessary that these elements are not sorted. These elements are not sorted in either order. We have to apply same algorithm for this and this, because 7 is at its right position. No need to pick this 7. We have to apply same algorithm for this and same algorithm for this. So from LB to end minus 1 and from end plus 1 to UV. Now I will write an algorithm to understand this concept. So we have to write this algorithm: partition of A, LB and U. This is the algorithm for partition. Now we have to select pivot element as A of L, B. Start is our LB and is our UV. By less than by A of start pivot start plus now while A of and greater than pivot So this is the algorithm or